已解锁，请取出话筒。
今天你比的，OK，我是用你的电脑还是？OK。
So, good morning, everyone. Today I'm going to study one of the important topic in project algebra and the module overring. Module theory is important because it generalizes many structure we already know. So, for example, the vector space module over field and variant group module over integer and idea of ring module over the ring itself. And before giving the formal definition, and let's recall what happened in the linear algebra. A vector space consists of an abelian group under addition and together with the scalar multiplication. And the difference is that vector space will use a field as a scalar system, and in module theory we replace a field by a general ring. So let M be an abelian group, and recall that n equal to the homomorphism M is usually a ring, and its elements are group homomorphism from n to itself. And the addition is defined pointwise, and the multiplication is composition, and the identity element is the identity. And a left action of a ring R on M is a ring homomorphism sigma, and this means every element R in R is determined an endomorphism of M. And in other words, every ring element acts on the module. And we claim that the pattern of a homomorphism as below, and is equivalent to a function rho Rm back to M. And it's satisfying below 4 axioms. So the first axiom is the scalar multiplication distribute over addition in M.
Maybe you can talk about
Sorry,
your laptop.
I already. Oh, okay. So the second action is the addition in the ring distribute over scalar multiplication. And the third action is the associativity of scalar multiplication. And the order is important because the R may be non-commutative. And the next action is the identity element of the ring X trivially. This claim tells us that the ring action can be described concretely using scalar multiplication instead of writing sigma Rm, we usually write as below. So the abstract homomorphism sigma become ordinary scalar multiplication, and this is exactly analogous to linear algebra. And the next definition of lab module consists of an abelian group N together with a map, and such that for all Rs in R and Mn in M, so the next one, for every module element M in M, and 0 times M equal to 0, and these identities follow directly from the module action. And below is a proposition. Every abelian group is an integer module and in exactly one way. So this proposition is extremely important because it tells us that the abelian group equivalent the Z module. So module theory generalized abelian group theory. And the next definition, so module homomorphism preserve addition and scalar multiplication, and so it's actually goes to the linear transformation in linear algebra. Our module is denote our and its object are module and its morphism are module homomorphism.
You get your mic closer.
Oh, okay.
You try to speak up.
Oh, okay.
Don't speak to yourself.
And the next example, if R equal to K is a field, then R modules are precisely vector space over K. And this example shows why module theory is a generalization of linear algebra, and every vector space satisfies the module action. However, the module theory is much broader because ring may lack of the multiplicative inverse. And example 1.6, let alpha be the method S be a ring homomorphism, and we define S below, then S become an R module. So a ring homomorphism allows elements of R to act on the element of S, and in particular, taking S equal to R, and alpha is the identity, and we see that every ring is naturally a module over itself. And the next definition, we let R be a commutative ring, and R algebra is a ring homomorphism alpha, and such that alpha R lies in the center of S. And this means that every element coming from R commute with any element of S, and R algebra is therefore a ring and R module, and with compatible multiplication. And polynomial rings is the most important. All quotient rings of polynomial ring are also R algebra. And next one is the homomorphism set. Suppose R is commutative if N and N are module, then the homomorphism R mod NA is itself an R module. And the scalar multiplication is defined as the R by M equal to R by M. And the next one, submodule. A submodule N of an R module M is a subgroup preserved by scalar multiplication. And that means that the Rn is in N for all R in Rn of N in N. And the submodules generalize the subspace in linear algebra and is ideal in ring theory. And to verify a subset is a submodule, we check the closure under addition and additive inverse and closure under scalar multiplication. And next example, reviewing R as an R module over itself, and the submodule of R are exactly the idea of R. This example connects module theory directly with the ring theory, and idea is simply a submodule of the regular module R, and thus the idea can be studied using module theoretic technique. So the next example, so an idea is simply next example, by function and is a module homomorphism, then the kernel phi and image phi are submodule. So the kernel consists of all elements set to 0, and these are the fundamental construction through the algebra. So the next example for R in R, and the Rm is a submodule, and if I is an ideal of R, then the Im is also a submodule. So the next one, quotient module. Quotient module generalize quotient group and the quotient vector space, and the idea is that element differing by an element of n are identified. So the quotient module collapse the entire submodule n to 0, and so we also can claim that and this define an R module structure on n mod n. The next one, the universal property of quotient, and the theorem, let n be a submodule of n if phi of m mapped to P is a module homomorphism satisfying and subset of the kernel phi, and then there exists a unique homomorphism of R module as below, and such that the following diagram commute.
You have proof for this?
Let me check. I only got the example.
You try write for this. This statement is like appearing in group theory, ring theory. So it should be similar here.
Little
bit.
Yeah.
But no. I mean, like I said, this theorem
Yeah.
is appearing in group theory, is appearing in ring theory. So the program is similar. And understand what I'm saying?
Yeah.
And then also I commented like for notes, right? Those we discussed on the board, right?
Yeah.
Can you like please add them in?
Okay.
Because I I realized that you take picture as well, right?
Yeah.
Yeah, can you like add those things as well? Okay, you can continue.
So I continue.
Yeah, okay, good.
Next one, canonical decomposition. So for the theorem, every module homomorphism phi may be decomposed as the M to M mod kernel phi and followed by as above.
You have proof?
No.
Do you realize that we did a similar thing before?
Yeah.
Where?
Is it this one?
Oh, it's presented by your classroom.
Oh.
I mean, like, I did it for set and then someone did it for group and then ring also. So now module again. So you should try and practice right now.
Okay.
It's really similar.
So the next one, first isomorphism theorem. So we have some corollary and if phi of M map to M prime is surjective, then the M mod from the phi is as above. Actually, I don't have time to study about this.
It's your obvious. But then like, I mean, okay, you don't understand it, okay, but then I think even presentation, right, you like need to like don't have time to study about it. How should I comment? That's fine. Study now. Oh. Okay. So what do you do if you don't have time to study about? Ask your classmate. What they do? Is that something that you don't know how?
That's why sometimes I cut down some material that's not that's hard for me to understand. I focus on those that are more difficult. That's how I feel on the last presentation.
Thank you.
Okay. Maybe I can tell you some way to save time. Did you realize that these things come out already and before? Didn't realize. Didn't realize. No. No, right. So
Yeah.
I think there are a lot of things in this world actually look the same. I invite you to see this. I invite you to try and see this one differently. There's a lot of things is the same. I didn't say same like chair and the table have to be the same. But then there are some property that having is the same. They're similar. Then this could save you. You understand? So one thing you learn in one place, it can be used in another place. It's not like, oh, this is different thing, I should use different way. No, it's not like that. There should be similarity. Not 100% lah. 80% or so. You understand? So if you realize that these things are actually we learned in group theory, ring theory before, saves time already. You no need to start all over again. You understand?
Yeah.
The whole course about this graduate algebra is these structure, group, ring, module that have similar structure. So that's why I asked you guys present, because it's the same link again 3 times. So if you didn't realize this, then this is a very sad thing to do. You understand? So I invite you read this stuff again, see what's the relation between group ring. Just now you mentioned very good points. Those points you understand. Yeah, I think the thing that you mentioned before, right, is very makes sense, it's very good, and actually better than the previous presentation. But then up to this part, then something goes wrong again, then I question you that you are very honest. So I think it's good. But then so hopefully that you can realize that these things were already did it before, actually. So how about the next 8 pages? You understand or not?
Mhm. Maybe a little bit.
A little bit.
Yeah, just glance through and write something on it.
Okay. Yeah, try.
So the for the third isomorphism theorem, this theorem said that the quotient can be performed in stage, and instead of quotient by P immediately, we make first quotient by N, and then quotient again by the P mod N, and the final result is the same. Uh, the end result. The end result.
Yeah, same as well.
Between these two, P mod N and the N mod N.
What do you mean by the same?
The
Okay, I'm not asking you about understanding yet. I'm asking you about how to read this thing. So if you cannot read this thing properly, right, you don't need to understand it anymore. Understand? You have to read it properly first. Like what you read for first isomorphism theorem also. As above, what's above? I don't know what's above. Above so many things. Right? So you need to read this sentence properly first. Only you can start understanding. Otherwise, you will don't know what you are trying to understand. Then you get stuck forever, wasting your time. This is how your time get wasted. You have to read the sentence properly. Try read it again in your own word.
So you mean the last sentence?
The whole thing.
The M mod N and do the mod again and P mod N. Is it equivalent to MP?
Yes or no?
Yes.
Yes, because it's a proposition. So you need to prove it. Why is it true? So you need to like convince yourself like why P mod N is a module, and M mod N is a module, and why P mod N is a sub-module of P mod N. And then prove that this quotient is isomorphic to M mod. So to show isomorphism, what do you need? Forgot already. Okay. So isomorphism is a bijection. No one's bijection. So you need to produce a band. Then show it is a
So it's bijection,
addition.
injective,
Yes.
and surjective.
And then this is an isomorphism. So we need to show that it is a ring, not ring. Module as module morphism. You define module morphism.
I think above all.
I think I remember you mentioned something about vector spacing. It's very similar to linear method. Category maybe before category. Okay. 1.2, see here 1.2. 1.2. And go down with. Yeah. Module homomorphism. So you check this. You add the proof it. Yeah. Can you fix your last note here?
Yeah.
You already fixed? You haven't
I
said.
already fixed proof in my note, but I haven't added it into the LaTeX.
Oh.
So next one is the second isomorphism theorem. We have some proposition. We let N and P be a submodule of N. Then N plus P is a submodule of N, and the N and P is a submodule of P. And below here are equivalent.
What's it?
M plus P over N are equivalent to the P N and P.
If it's a new thing, I try not to say like below, above. Try to say what is it. If I can say below, above, I just say here it is, here it is, then you go and read yourself. You understand what I said? You understand what I said?
Yeah.
If it's a new thing, right, try and read it out properly. If it's something that you keep mentioning, okay, you said above is okay. But then it's a new thing and here, n plus p over n. Isomorphic to p over n. Intersect with p. This is like you think about this before. I didn't tell you. You understand or not? So the attitude you read this statement, right, can affect how you appreciate it. If you just say, oh, below is like this is like, oh, I don't care. It's like this, You understand or not? This is your attitude, How you present is your attitude. How you view the importance of the statement. From your presentation, I can hear like how you see the thing. You don't know there's another story, but then you need to at least appreciate what you
Mm.
You know.
So the next section, product and co-product in R mode. For the direct sum, we let M and N be R modules, and we define M plus N. The operation are defined component-wise. And the elements of the direct sum are ordered pair, and the direct sum allow us to build a larger module from the smaller ones. And this construction behaves similarly to the Cartesian product. Next one, the universal properties of direct sum. For this proposition, the direct sum n and n satisfy the universal properties of both the product and co-product. And this proposition is important categorically. For product and the given maps phi m p map to n and the phi m p map to n that exists a unique map. And phi m and the product of the phi n and phi n is defined by the product of phi m and phi n p equal to the phi n p and the phi n p for whole product. So we have the diagram here to show the relationship, and that is for all m in n and all n in n. And the next one, since the psi m and the psi n times with the identity equal to psi n, and we obtain the psi n and the psi m, and n equal to the psi m plus psi n. And this is an R module homomorphism since it is a homomorphism of abelian group and it preserves the action of R. And since it's a unique R module homomorphism, and so the diagram is commute, and this verify that n work as a coproduct of n. So the next slide is a kernel and the co-kernel. We let the phi m at the n be a module homomorphism. So next one is the definition. The co-kernel of phi is a co-kernel phi equal to n mod image of phi. And the proposition, the following holds in R mod. The phi injective equivalent to the kernel equivalent to 0, and so as the phi surjective equivalent to the co-kernel phi equal to 0. And the kernel measure a failure of the injectivity, and the co-kernel measure the failure of surjectivity, and these concepts are fundamental in category theory and homological algebra.
Can I add the proof?
Okay.
Yeah.
The next is a free module. Let A be a set, and we define the RA equals to the set, and we claim that the free R module on A is isomorphic to the RA, and every element may be written uniquely as a finite sum. And the free module generalize the vector space with bases if the A equals to the set n, and then the RA equivalent to Rn, and this is the module theoretic analog of the coordinate spaces. The next one is a free commutative R algebra. We let the A be the set, and then we define the RA equals to the Rxn to Rxn, and the proposition, the polynomial ring is RA is a free commutative R algebra on the set A. And we have the proof. This means that every function fa mapped to S is into a commutative R algebra as Sn uniquely to an R algebra homomorphism phi Ra to Sn. And then the proof we use the extension property of polynomial ring. So we construct the phi, and as I mentioned before, it's by repeatedly applying the extension property of polynomial ring. So we continue inductively, and then we obtain the result. So its extension is uniquely determined by the required image of a new variable, and the phi is uniquely determined. This gives phi as a ring homomorphism. And moreover, since phi extends the structural morphism, then the alpha is automatically an R algebra homomorphism. And therefore, Ra is a free commutative R algebra on the set A. And next one, the submodule generated by a subset. We let A be the subset of N, and the submodule generated by A is the A and the set below. And so the next definition, and module M is finitely generated if M is A for some finite subset A in M. So the finite generation means finitely many elements generate the entire module, and equivalently there exists a subjective homomorphism Rn to M, and thus finitely generate the module quotient of free module. And the next one is the Noetherian module. So for the definition, an R module M is Noetherian if every submodule of N is finitely generated. So the Noetherian module satisfies a finiteness condition, and the submodule cannot become infinitely complicated, and this concept is foundational in commutative algebra and other subjects. And next one, the proposition. Let M be a submodule of N, then M is Noetherian if and only if both N and M mod N are Noetherian. So for the proof, suppose first that N is Noetherian, and every submodule of N is also a submodule of M, and hence every submodule of N is finitely generated, and so the N is Noetherian. So similarly, the quotient module of Noetherian module remain Noetherian. So conversely, suppose n and m mod n are Noetherian, then we let P be a submodule and then the P intersect n is finitely generated because n is Noetherian, and by the second isomorphism theorem, P over P intersect n is equivalent to the P plus n over n. The right hand side is a submodule of n mod n, and since n mod n is Noetherian, then is finitely generated. Therefore, P over P intersect n is finitely generated. And combining generator of P intersect n and P over P intersect n shows that the P itself is finitely generated. Hence, the M is Noetherian. So we also have some corollary. We let R be a Noetherian ring and let M be a finitely generated R module. Then M is Noetherian as an R module. So
It's like fine.
okay.
Send proof as an exercise problem. You can make that problem do the necessary.
Okay. So can I continue?
You compare the breakfast.
And the next corollary, we let R be a Noetherian ring and let M be a finitely generated R module. Then M is Noetherian. And we also have some proof. Since M is finitely generated, there exists a surjective homomorphism Rn to M, and by the first homomorphism theorem, M is isomorphic to a quotient of Rn, and so it's sufficient to prove that Rn is Noetherian. And this is done by induction on N. And we, the case N equal to 1 follows because R itself is Noetherian. And we assume that Rn minus 1 is Noetherian, then the Rn over Rn minus 1 is equivalent to R. Since both of them are which is the Rn minus 1 and R are Noetherian, then the proposition implies that Rn is Noetherian, hence M is Noetherian. So the last section, the finite type, and we let S be a commutative R algebra. For the first definition, the algebra S is finite over R if there exists a surjective homomorphism of R module Rn to S. And the next definition, the algebra S is of finite type over R if there exists a surjective homomorphism of R algebra. And the finite type means that the finitely many algebra generators are sufficient, and the finite means finitely many module generated are sufficient. So the next example, the polynomial ring Rx is finite type over R, but not finite as an R module, because the ring Rx is generated as an algebra by one element X. However, as an R module, it requires infinitely many generators, one x squared, x cubed, and something. Hence, is finite type but not finite.
So finite type, what's the end?
Sorry?
Says finite type, right?
Yeah.
How do you define finite type? So then the surjective formula algebra.
Yeah.
You can write down what you say. Why is it not finite? It's finite is R algebra is just because you can map Rx to Rx. So what you say is like what you figure or what you read from the
I don't understand, so I ask AI and then
Do you understand what the alpha?
partially. Yeah.
Okay, I can confirm.
I try to understand.
I can confirm that what AI says is correct. So you should try and think about why what AI says is correct. Yeah. Because as you say, man, our module is like a vector space. So you need to ask yourself what is inside this polynomial. For example, 1 plus x, 1 plus 2x, 1 plus x squared, speed. So I'm not sure you learn enough vector space. For example, R2. You know R2?
Yeah.
1, 0, 0, 1, 1,
Yeah.
1, 1, 2, right? Okay. So you can write those things in terms of basis. So basis meaning, for example, the vector 1, 2 is written as 1 times 1, 0 plus 2 times 0, 2. By saying 1, 0, 0, 2, the vector. The 0, 1, sorry, 2 times 0, 1. So 1, 0 and 0, 1 become a basis. Linear combination of these bases can get you every element. So here is the same. So you need to have linear combination of 1 x squared cubed, like what you mentioned just now, to get all the polynomials. And as an algebra is the definition equal to. So you can view a subjective polynomial from x to Rx. So what does it mean? I think it means that when you see it as an algebra, you see from a viewpoint of polynomial ring. But then when you see as a module, you need to look at basis. And finite type and finite over R is different. So they are two things here. Is this finite over R? Is this finite over R?
Yeah,
R
finite over.
over R? Or finite pi over R? That different. F.2 and F.2. Is it still finite over R?
Got two definitions. The definition 8.1 mentioned about finite.
Yeah, that's what I can see. This algebra finite over R.
No,
Huh? No. What?
because it's finite type.
Maybe you can do an exercise. You go and find like, is there any finite algebra but not finite type? And then not finite algebra but finite type. And then the four possibilities. See if you can get all of the examples. Or maybe one of them is implied by the other. Then you understand what I said? Yeah, try and add those examples. And then try to verify if F.3 is finite over R. It didn't say that one is a complement of the other. At least you have a proof in here. But I don't think so. I think finite is not finite is an R module. It's F.1, I guess. I think. But you need to verify. I think I think not finite as an R module implies not finite. Find finite R module. Do you define finite for module? I think this is not finite, it's F.1. I think this phrase here is F.1. That doesn't have this such a thing. But then the way you present just now is like different way. So you need to see those bases. This R, I mean, there are problem about it. It's a one-dimensional module. And then one-dimensional module over R is isomorphic. So that's why you know this R infinitely.
I think that's all my presentation.
Okay. Okay, in this case, thank you very much. So this ends our presentation for your period stuff. So please hand in your evaluation and then your notes if you haven't do it yet. 这样子 OK。那第三个，那个可以在前面几个东西有给我
有
有没？
有
经过好像没有收到，好像过来。 咁我没有收到你这个时候。给我一个语法，有没有？这就是对呀，挺高的。人有没有 like 资源的里面？这个，你看他的
那是谁？
他的一个资源一个，还有他的本身的，没有那个是多一点。
不用紧，我再写。不用紧啊，我再写过。
对啊。第三次了嘛，第二次的已经过了。没有，
嗯
没有，
，OK，
他们两个人没有。
哦，我再写。
你有写过？Okay, okay, then for the rest of the semester, then we will continue with homological algebra. Okay, so starting from this module places, so we will look at chain of modules and then the map between them. I think, yeah, and then I think there's one more presentation before the end of semester is your project. Okay, so that will be left up to the end of the semester. I think we will do it in one of the class time. Okay, one of the class time. And then hopefully through this presentation, right? So in future, you're gonna do researcher or you continue with your postgrad, you will often attend this kind of a seminar of some sort. Hopefully you can mm, benefit okay from hearing what people say and try to ask question or what uh, because usually this kind of seminar, right? Because when you go into the front end, right, it will be very technical, okay, or professional. So sometimes if you don't work in that field, it's very hard for you to relate what they did. So one way to go around this is to hear whether what they say is coherent or not, okay, logical or not. Okay? Is there any contradiction or not? Okay, so these are the things you should learn to listen, learn to ask. Okay. So hopefully through this kind of class presentation, you can train your listening skill. Okay. I don't know, maybe the Asian kind of teaching is like forcing you to listen, right? Whether correct or not. So this is very bad for actually research. Yeah, this is good for brainwash, but this is bad for research. Okay, because you're forced to accept something is not correct. And then if something is not correct, then it's very hard to lead to real stuff. Okay, just cannot. Okay, so try to think about what people say. This is what I wanted to say. Analyze. Okay, analytic skill, very important. if that person is like very hard, I mean not harsh, very 叫什么那个东西，very 是 very stubborn, could be stubborn or hold on to his point very strong. I'm not asking you to like protest, but then you need to differentiate. You need to know what the person did is correct. You understand? Yeah. So this one is relative. Either he is stubborn or either you are stubborn. So you need to adjust yourself. If he really hold on his point very strong, you should try to understand why that person hold on his point very strong. Mathematics is like this. Why I like mathematics is because you argue to the end. You will see something that's very true. You understand? So this is why I like mathematics. So this could apply to your analytic skill. Okay, so if you think he is wrong, and then but he still insists, you can try and think what's the reason behind that make he or her like that. And then you found out that, oh, this reason is all like that. Then you will know that, oh, he do this because of this or like that. Either you can help him or either you understand that why he is like that. Understand? But then this process is like not how to say instant. It's not instant. Maybe it takes some time. Okay, it takes some time. But then this will come with experience. Once you experience a lot, then you will see that, oh, this is because of this, this is because of this. Implication. If then. Yeah. This is a bit like fortune teller, right? Fortune teller, you know, fortune teller? Fortune teller 不知道，算命师啊。It's like you tell him something 啊，对，你祖上做了这个事情。So it's like, this thing is like happening oftenly, okay, always. So they already know that, oh, this is the reason, something like that. Obviously, sometimes it's not accurate, but then based on majority, it's like that. Yeah. Okay, this is what I wanted. So hopefully you can take this opportunity to learn how to listen to the presentation and how to analyze presentation. Okay. Yeah. Okay. So let's take a break. So should we extend today's class? We can have a lecture, huh? 我还是有点累，因为今天他们要考 midterm 其实。Are you guys around or you guys not here for this week? 你们等一下会有来吗？会在哦，因为actually this week 的 tutorial 他们是做 revision 罢了，所以如果你们有在的话，可能可以帮忙 invigilate。Other than that 的话，我们就 other than that 你们可以 freely 做自己事，或者你们可以回去也是这样。所以就想知道一下你们有没有来啊？对，因为那两个人我需要安排他们去其他地方跑，所以要帮我看着他们。我要还 tutorial 啊，yeah. So that's why 我问你们有没有在那个群里面。你们可以 stay 啦，如果你们要在那个 tutorial，but then 我不确定等下会发生什么事情，but then 我会给他们 revision，等下会讨论一些 concept 这样啊。对，类似像上课啦，就是 revision 哦，go through important But then 我是需要至少两个人去帮我管人啊，他们要在其他地方考试，在上面啊，其实02。呀，你可以干你的自己事，就帮忙看看他们吧，他们应该不会出什么事吧？呀，就带他们去上厕所啊之类的，要跟他进去厕所里面。Okay. So for your notes, right, try to add in the proof, as many proof as possible. OK 吗？你们等下会在吗？还是有在吗？你们还是回去都可以的。我们现在应该大概够人吧，至少。 2个 batch 一起，所以我们是一次过删掉啊。either 我们会到2个小时，either 如果早结束就早完哦，那我们回去休息哦，下午考试，他们下午考试。如果下午你要来也是可以啊，我有放那个地址，课时时间我有放，是没有，我跟他们讲，Yeah，如果没有什么，你们这周可以不用来先哦。如果你有来，让我知道。就办，so I think we are on track 啦，actually，我们还有半个 sem，所以我们应该可以做很多 module 很多意思，感觉很多啊，module 的一个就是，yeah. Because I'm not trying to focus on this Noetherian stuff actually. I want to use module to do homological algebra only. See if we really need to get deep into module, like Noetherian stuff, we need to go through it. I think assignment I will try to come up this week for ring assignment, and then I'll try and return your group theory assignment soon before the ring assignment due. Okay. So far, what do you think about the assignment? Is it like too hard or not? Too long, huh? 60 cases on. Okay. So long. Okay. Okay, let me see if I can produce shorter page length answer for you. Okay. Let me see if I can simplify that solution or not. I haven't read your solution yet. Let's see. And then I think one of the question got problem, is it? I haven't read closely yet, but then I'll try and verify it. Yeah. I'm not sure the step exchange example makes sense or not. I haven't read closely about that. So I need to verify it also. Once I verify, I'll let you know. One thing about your presentation is please focus on saying something that makes sense. Okay, don't try to rush over things. There's no point to rush over things because what you present is actually in the book. We all can read also. So no need to rush on. So what you need to do is to make sense of things and then try to engage with your audience. Make sure they understand also what you say. Otherwise, no point, right? You are just saying to yourself, why not just go outside and say? So make sure that when you speak to people, make sure they understand what you say. If the people like not trying to understand you, then there's their problem. But then you need to at least do your part. If people already try to engage with you, you need to engage, right? Because sometimes there are some presenter is like doesn't care one. They say what they say, and then they don't care whether you understand or not. 没有啊，很多人是这样，很多人是这样。不管是老师还是什么人whatever，老师可能会更明显一点的。But then, so try to engage with audience. In particular, if the audience want to engage with you, you have to try to engage back. So sometimes you cannot respond on the spot, right? So there's a technique. Is to say that maybe I'll come back to you later, or I haven't think about this enough yet. You don't need to force yourself like very nervous or what, stand there. I don't know how then no need. You just say that, oh, I'll think about it again and then I'll let you know. That's a very polite manner. It's okay. Yeah. People is not also forcing you also actually. Yeah. So they cannot force you also if you don't want to say. So you need to know what's your right. I mean, when you present, this is very important. This is seldom seen in this Asian kind of setting. I mean, at least from my since young, how I like see this teacher or whatever or our community because we like to force people to do things, right? But this is different when I study in Australia. Yeah. So they are like very free one. If you can do, you do lah. If you cannot do, you don't do lah. What? If you talk more than what? 听到他讲吗？我听不到。反正我们不是下课了，我们就下完了，不是下课了。对啊，我们不是下堂课再继续咩？行，因为你没有 extend 了今天，不然的话我们就 extend 1个钟，就1个钟我才可以讲课，那讲个半个钟就讲一半半，对不对？所以我们做一个 summary I mean like conclusion for this presentation. Hopefully next presentation you'll do better. Yeah. I think some of you are improving. Okay. Yes, some of you are improving, which is very good. Keep improving because I think you seldom get this kind of chance actually to freely do what you wanted to do. Yeah, because people will have like I was a 条条框框 I guess. A lot of weird rules that doesn't make sense sometimes. Yeah, I mean like Australian study actually gave me a lot of open up my mind actually. Because when I study for like primary school up to like pre-U, right? After class, definitely I go back and do exercise, non-stop tutorial, homework, whatever, revision, whatever, just to do until sleep. But then when I went to Australia, there's a very relaxed manner. I still do tutorial, do exercise, but then their deadline is not like, how to say, I don't know, it just feel different, when I come back for work. You feel the tense environment, it's like very weird. Australia also got deadline, but then it's not like that. Okay, maybe I can tell you like for Australia how they work. It's like Friday afternoon, basically they come out for afternoon tea already. Thursday night, people after working, they go bar already. Okay, when I work with my supervisor, he didn't really set some deadline. So maybe sometimes I also feel bad. I think this week got no progress or what, but then it's not entirely my problem also because he don't want to see me also. But then he don't care also. He doesn't care as well. I mean, maybe he care about my graduation. So he will make sure I can graduate first. But then other than that, he didn't care. He didn't say, oh, this week you must finish this. That's week you finish that. No, every day I go play badminton. If I don't do research, I go play badminton already. The whole morning I can play badminton. Then I come back, I study. So it's like flexible. It's very flexible. You understand? But then here is very weird. They got deadline, but then deadline is like really dead. It's like you do until die. It's very weird one. So how should I say about this? Maybe one thing about the people here is like sometimes people are stubborn. Because if you don't really fix a real deadline, they will like try and drag you out. But in Australia, we are very following law one. For example, the COVID, it's very very how to say 有秩序very 就是排队的时候有秩序，就是 like how to say very systematic when they handle the COVID. If you watch the China or what, they are like lining up for a long time, still haven't get the vaccination, right? So they are very systematic one. And then we are also very systematic. We go there, we just chop and then leave already. We don't stay there for long or what. No, nothing like that. No long queue like that one. And if there's a queue, it's very fast. So it's very systematic. So they come up with a rule, we follow the rule, very easy, done.
No arguing one. You understand? So you need to, so what do I mean by this? So you need to come up with a rule that makes sense first. And then you ask people to follow. But a lot of time, I'm a lecturer, right? This one of the decision making, right? I'm in the meeting, you know. Sometimes they don't want to answer you, or why will you do like this, you know. Even I am a discuss. I'm in one of the discussion, you know. So that's why I can understand you, you know, you guys. Because even I'm a discussion maker, decision maker, I cannot say things, you know. This is very bad, actually. This is not listening to opinion. I already see got problem. Then you don't want to accept what I say. This is very bad. Yeah, this is one of the bad things happen here. Okay, in Australia, for example, we are tutor. We can mark exam, right? So we can ask, or the lecturer can tell us like what they want to do, and then we can tell them like what happened here. So this question got this problem. So how to fix? So it's like very democratic, right? Yeah, and then the lecturer will take in our advice, and then they will do some exchange. I mean, changes in their teaching or whatnot, course design. Yeah, this is how it works. Yeah, I think make more sense. Maybe you in the old time, maybe this kind of teaching is because we are not educated yet. But then nowadays, the kid is different already. They read a lot. I mean, through videos, even know more than maybe the adults know. Yeah. So we should be treated differently already. So if you look at the paradigm of this world, it's also shifting to Asia also. Economy is already shifting to Asia. Yeah, education is slowly shifting to Asia. Yeah. Because in those Western education, right, too free. Sometimes they are too free. If you look at their textbook, I try to tuition 7 more minutes. I tuition one of their high school students. If you compare our SPM textbook with their textbook here, maybe 12 or 11. The exercise or every section only got 2 to 3 exercises. If you look at our exercise, it's like 10. So I was saying that this kind of training not enough for them. Not enough for them. It's good that they emphasize on concept. It's very good. But the exercise not enough. Okay, so we are not taught by concept. We are taught by exercises, questions, right? So once we see the question, we know what this question try to ask. So this is how we learn. I mean, at least how I learn. But then for them, right, they are like try to understand the concept, but they do exercise. But the exercise only got 3. It's not enough for them to like get enough practice, you know. Where whether they want to do or not is another question. But then you should provide enough exercise to them. This is what I wanted to say. So we need to try to get a balance between these two. Yeah. So in Western education, if the people is very good, super good, then it is very good one. If not good one, then maybe very bad already. Can't really do stuff. If you see news, I think there are news saying that they can't calculate even they go to or high school or pre-U. Can't calculate things properly. They got the idea, but they cannot calculate. This is what I meant in my tutorial also. In the tutorial, they can discuss everything. But assignment, like shit. Cannot write stuff. So there's good and bad between these two. Yeah. Yeah. So we need to try and balance these two things here. Try to balance between these two. So whenever I teach the course, any courses, I try to balance between these two. So if they know the concept, they have to know how to calculate. If they know how to calculate, they should know the concept. These two have to come hand in hand. It's a very hard thing to do, actually. It's a very hard thing. Even when I explain to my boss, my boss said, can me? I learn calculate already, still can learn concept. Can I don't know can or not, but then I keep trying to do it. Yeah. Two things. Okay. Try to think about this when you present stuff. Because if you notice what I do in my asking, right? Sometimes I ask you to write down the proof. Sometimes I ask you why this proof was like this. So this is the main two principle I try to test you. Whether you understand what you do and then you understand what you say. Yeah. And then mathematics is something that cover these two things at once. Okay, otherwise it will become arithmetic in one side. In the other side, then it will become an abstract nonsense. This is the two end you will go if you don't go toward mathematics. Okay. Anything I need to update you, or you have any question about this course so far? You like know what to expect? Next. Yeah. No. Okay. Or you have some idea or suggestion on learn better to help you learn better, or learn more, or what? So. Yeah. Yeah, it's a good thing that you asked AI. Yesterday, I went to an AI workshop. They mentioned about AI, and then AI in research. There's a lot of application AI publication, and then they use AI to check this publication. And then people use AI to do references, and then caught that these references are wrong, something like that. So one way to go about this, right, is through presentation. Is through asking, interview, okay, whether you understand or not. Okay, so AI tell you this. Okay, so can you explain it in your own words or not? This is very important. I mean, this is not just about AI actually. Before AI, you also can just read textbook to me, read different books to me. So what is understanding, huh? This is a very big topic. Actually, this topic actually surround me throughout like 3 years of my teaching actually. Because when you say comment that this student don't understand, the student claim that I understand. So what they understand actually? Yeah, so this understanding is not an absolute thing, It's like a relative. So Chinese, there's a very good saying, 温故知新. So every time you revise, you will learn something new. So maybe I would say that understanding is like, can you say one thing in 100 ways or not? Maybe 100 ways. Can you say it in 100 ways? This is also how this field advanced actually, mathematics. You try to relate one thing to the other thing is like, can I understand this thing differently? Are they equivalent or not? Or is a subset? Or there are more things that we cannot cover here using this. So it's like saying one thing in different things. For example, land program. So we are trying to like relate algebra to analysis. Actually, these two fields is the same. So this is what we keep asking so that there are more research topic coming out, research direction coming up. Otherwise, then you just understand to the state that that people know. People know, meaning others people know. Not sure you know or not. You understand? So you need to learn to develop your own idea. Once you develop your own idea, maybe there's a new direction, coming up that people never see, which can be done. actually, because every person is unique, so they have different way to think about things. So developing own ideas is very important, super important. So have you guys any this stuff? Yeah. Okay. Yeah, especially this is a master course. Okay. In undergrad, I keep emphasize this, right? But then you understand some undergrads are just coming and earn a degree and then leave already. So they don't really care. But then you are master already. So try to have a mindset change. Mindset change. Also because this degree actually is a theoretical degree. It's not like an engineer 1 year then got my brother is doing that. UTM. Actually UK also do that, 1 year master degree. They are like claiming they learn nothing from. It's like a program to earn money or just to give you a credit credential. But then this is the pure degree, so you have to learn some idea. Otherwise, this is a waste of time, right? Waste of time. Okay. Hey, yeah. I wanted to ask, did you do research when you come here? I mean, research on this course. I mean, not course, not the degree. Master degree. Our master degree. You think that is what you wanted, what we offer. But when you come in, you still think that it's what you wanted to do. Oh, okay, good. 90%. Then 20% is very good already. 90% is very good already. It's a high statistical rate. Because if it's not, then we need to like check back our marketing. What's wrong with it? I think so far it's okay because I think we are updating our pamphlet also. I think we'll try to distribute to public. I'm not sure when it will be done. Get done. I mean, like we can also promote the private U postgrad as well. It's just to build a good ecosystem, postgrad ecosystem. Because you understand that once you change the environment, right? I think it's better for your development. Like if you just stay there forever, yeah, you just change it. I mean, like you'll be still the same. So you can exchange good students, actually. Okay, I think time's up. So we'll start new stuff next week. Yeah. Hey, I need to get update of your topic soon. Because now you also do deeper research already, right? So I think you have a better idea of what you want to do. Correct. Correct. Oh, no, correct. Correct. No, correct. Okay. So maybe I'll get a more accurate topic from you guys. Next week. Is it next week okay or not? Or you still need more time? Is it okay? Like because sometimes the topic I gave is like very broad, right? So you try to decide down like what you have to do exactly. Also, you can try keep discuss with me what to do. Yeah, because I don't want too long stuff also. But I want it to be compact. I don't want like bullshit. Okay, compact stuff. Try to learn about certain topics, which is the extension of this course. I think now we learn up to modules already, so basic tool you have already. But then maybe some of you are using chain complex, right? So I think you need to read advanced stuff first. But for groups one, I think we're basically done. Ring one also done already. No. Oh, our Tuesday holiday is coming soon.
方法都不同，不同的没错。
I think we still got one more hour to repeat to see how it goes. 其实如果有一天我们把那个1小时直接做掉，也是可以，可以，可以不？Because we got a 1 hour room there. 如果我们真的要的话，如果也看情况，或者那个 1 hour 我们可以就是拿来做那个 seminar 也是可以的，就是你们的 seminar，yeah presentation。
他们一个 presentation 要多久？
没有想，我觉得20分钟够吧，15到20。
都太长了。
没有太长，你也没有这样长东西讲吧？
不知道啊，
就10面吧，我给几面10到10啊，
好压力哦，4个 project 要做，还有对
4个
还要有4个考。
对，因为你们没有 midterm 啊，so that's why project component 会大一点。你可以想象是一个midterm 吧，但我给你长一点时间，something like that。
大概讲大概的 concept。
不用那种很 tedious 的 proof 啊，然后如果有那种很 tedious 很长 proof，你至少也要讲一下它的 IU，就是它的呀，不要讲到那种的很细的东西，inequality 嘛，讲不用，就比较简单的 proof 可以直接讲出来，比较长的那些 proof 你可以讲一下它的 idea 啊，为什么 probability 啊，讲它的重点啊，你不要什么 let 这个等于这个不用了。用每一粒字都念给我听啊。Yeah, because you're gonna write inside your project, right? So the main point is like to explain your project, basically, before I read it. Or when you present, see whether what you write makes sense. Okay. I think I will ask you to hand in after you present. So you still got chance to change. So I think we will do it in maybe week 12 or week 13 presentation. Only 1 more week. week 13 I think 12 or 13。哎，你们 FYP 几时 present 12？OK， 这样你们13，行了，这样真的到13。Then we fix 13呢 ？Maybe I think it's Friday 啦。Maybe yeah Friday。I mean like 可以吧？可以啊。Yeah。I mean 我还有时间教课。对吗？明明50%，当然不是100万，2个钟呢？对啊，如果 extend 的话，有1个钟。OK，不要了，不要 extend 了，真的。但是我们就就把一个周5变成 presentation， 因为100除2是50。哦，所以对啊，因为50加5，我想一下，哦，如果加 Q&A 也可以哦，那种。
大家越来越就得
好像半个小时，如果没有的话，就2个钟就进去了。
身边会有半人，所以要时间啊，来的时候人多来一起也要时间。
这样也 make sense。这样我们就放差不多 present 20到25分钟，加上 Q&A 的时间了。And then 这样的话换人什么的话，我们就大概就3个钟这样。这样我们就可以把那个 extra 的 one 丢到了 presentation 那去。
那2个就够了
啊？
那2个就够了。
可能还要休息一下中间。OK， 也是可以。It's okay. Okay, we will say this again. For now, we can plan. OK， 所以你们3个等一下有人在那个，可以带进去。OK，
要中间去拿那个白
就拜拜过来了。30应该是够人的，30应该够了。左右的嘛，啊，可以。
不能接到2个人需要2个人，
因为派一个人得要去厕所了。哦，因为有2个人来，如果1个人考的话，就1个人。
Sorry.
OK，拜拜。谢谢，拜拜。
哦，我其实有 feedback from 他们说你们对他们有用，帮助啊，他们讲啊，所以就继续努力。诶，那个配你的这个，
已上锁。
希望看一下他们这次成绩好不好？
哦，为什么？
先给。